Hi everyone, I'm going to show you the next astronomy equation that we're going to learn today, which is calculating the energy of a photon. Photon is a particle of light, travels in waves. You've learned how to calculate the wavelength and the frequency of a photon of light, so this is now just calculating the energy that that type of light contains. So this covers slides 12 through 14 in the notes. So I'm going to talk about the equation first and then do the problems on slides 13 and 14 for you, show you here. So E represents energy, capital E here. H is Planck's constant. It's always the same number. It's 6.626 times 10 to the negative 34th joules times seconds is the unit there. So this is just a relationship in physics that's always the same. So you're always going to use that same number, and same with the speed of light. It's a constant. You always use 3 times 10 to the 8th. We've learned that one already. And then that little fancy upside down y is lambda. That represents wavelength. So slide number 13 says calculate the energy of a photon of radiation whose frequency is 5 times 10 to the 14th hertz. And we need to calculate its energy. So we can't use that energy equation yet because frequency is not in the equation. In order to solve for energy, we need H and C, which we always have. Those are constants. But then we also need lambda, which is wavelength. And we don't have that yet. So first we have to solve for wavelength using yesterday's equation. C equals wavelength times frequency. So if I'm going to solve for wavelength, I divide out frequency. Frequency cancels out over here, and I'm left with 3 times 10 to the 8th, which is C. And don't forget to put these in parentheses when you plug into the calculator. Divided by the frequency, which was given to us, 5 times 10 to the 14th. Hertz. When you plug that into the calculator, you get the frequency is 6 times 10 to the negative, the wavelength, not the frequency, 6 times 10 to the negative 7th meters. Meters is the unit for wavelength. All right, so now I have everything to plug into the energy equation to get energy. So it's going to be energy equals H, which is Planck's constant, the 6.626 times 10 to the negative 34th, times 3 times 10 to the 8th, which is C, speed of light, over wavelength, which we just solved for, 6 times 10 to the negative 7th. Now, when you plug this into the calculator, you're going to plug in this times this in parentheses, hit equals, and then do divided by 6 times 10 to the negative 7th in parentheses. And the answer comes out to be 3.313 times 10 to the negative 19th. And the unit we use for photon energy is electron volts, EV. Sometimes energy is measured in joules, but with photons, it's usually electron volts. All right, slide number 14 is a little easier because you don't have to solve for wavelength. They give it to you. So 14, they tell you the wavelength of a photon of light is 3.3. And then there's a fancy U, it looks like this. That means micrometers, which is a micro is 10 to the negative 6th. So you want to put that in meters. It's given to you in meters. In parentheses. So that would be, I think it's 3.3 times 10 to the negative 6th is the wavelength that they give you. So you're going to plug in H times C, those two given values, divided by 3.3 times 10 to the negative 6th. And the answer comes out to be 6.02 times 10 to the negative 20th. So this is just one step further. Now that you know how to calculate wavelength and frequency, you can take it one step further and calculate energy. All right, now you're going to try some practice problems.